This tutorial reviews Bowen's reaction series, a very important concept when it comes to magma cooling and crystallizing. By the end of this tutorial, you should be able to explain that minerals in rocks melt and crystallize at different temperatures, and you should be able to give examples. You should also be able to give examples of specific minerals that have low and high melting and crystallization temperatures, and crystallization can be thought of as freezing as well. As usual, please try to answer these questions before I go through the answers. Just as a reminder, this is what Bowen's reaction series looks like. We have temperature high to low on one side of the diagram, and so as a magma moves from the top to the bottom of this diagram, it's cooling and crystallizing, solidifying. The minerals that form don't all form at the same temperature. The highest temperature minerals that form are olivine and a calcium-rich plagioclase feldspar. We then have pyroxene at a lower temperature, then hornblende, biotite, and along the plagioclase feldspar spectrum, we continue to a more sodium-rich version of the plagioclase. Finally, at the bottom of the chart, we have the lowest temperature minerals, potassium feldspar, muscovite, and quartz. So to help understand this partial melting or partial solidifying, I want you to imagine a solid frozen block of chocolate chips, ice chips, and butter pieces all compressed together. Imagine that the block is in your freezer and everything is frozen together. So you take this frozen block of these three things out of the freezer and you put it on the counter. What parts of this block are going to melt first? Well, hopefully you said the ice chips, because the ice chips melt at a lower temperature than chocolate chips or butter pieces. Two students are discussing what's happened to the chocolate chips and butter if the heating stops at about 5 degrees and the ice is just barely melted. Student 1 says the chocolate chips and butter will melt along with the ice because they're surrounded by melted material, so they should melt as well. Student 2 says no, the chocolate chips and butter melt at a higher temperature and the melted ice is too cold for them to melt, so the chocolate chips and butter would stay solid. Which student do you agree with and why? Student 2 is correct, and the reason is that each of these three items has its own melting temperature, and until that temperature is reached, it's going to remain solid. In the box below, place the words ice chips, chocolate chips, and butter pieces in the relative order of their temperature. So ice chips are going to be at the coldest end, then butter, because as you know, butter does get very soft at room temperature, and if you have it in the sun, it would probably melt. And then chocolate chips need an even higher temperature to melt. So let's apply this to igneous rocks. Bowen's reaction series, as I mentioned before, describes the order in which minerals in a magma melt or solidify. And the order is given in this list here from lowest temperature to highest temperature. So imagine that a sample of igneous rock is heated that has quartz, potassium feldspar, and amphibole, these three minerals. As the temperature increases, which mineral is going to melt first? Well, it's going to be quartz, because quartz has the lowest melting temperature of all of these minerals above. Give an example of a mineral that would stay solid in magma at 700 degrees centigrade and explain your choice. Olivine and pyroxene at this end of the spectrum have much higher temperatures of melting than 700 degrees. So they would remain solid in a magma that had a temperature somewhere around this region. And all of these minerals might also have remained solid, but probably not these down here. Next, we're going to think about the relationship between melting temperature and freezing temperature. Think about ice. What's the relationship between these two temperatures? Does it melt at a higher temperature than it freezes? Does it freeze at a higher temperature than it melts? Or are they both 0 degrees centigrade? And that is indeed what they are. So when it comes to minerals, the lowest temperature minerals are also the minerals that have the lowest freezing or crystallization temperature. The highest melting temperature minerals have the highest freezing temperatures. All minerals have the same temperature for freezing and melting. It's just that different minerals have different temperatures at which they do this. For our frozen block of chocolate chips, ice, and butter, which has both the lowest freezing temperature and the lowest melting temperature? And this would be the ice chips. Now, on Bowen's reaction series, we want you to label the following temperatures by drawing 4 lines to connect to the appropriate minerals. The lowest melting temperature is going to be down here at quartz. The highest melting temperature is going to be over here at olivine. The lowest crystallization or freezing temperature is also going to be quartz. And the highest freezing temperature is also going to be olivine. So I hope you see this relationship between the freezing and the melting temperature. Finally, we're going to look at this little microscopic view of minerals. And the minerals that form first in a magma as it cools tend to have a nice shape because they're not bumping into anything else. They're growing inside liquid magma, they have lots of space. As more and more minerals grow, they bump into those earlier formed minerals, and they might not be as shaped as nicely as those first ones. So based on the shapes of the minerals in this picture, figure out the order in which they cooled and then match the name with the mineral. So if we look over here, we can see 3 kinds of minerals: gray, white with some stripes or probably cleavage indications, and then these very rectangular darker colored ones, dark gray. So because the dark gray ones have very, very nice shapes associated with them, those are the first ones that formed. Those are the higher temperature ones that formed first. Next, it looks like the white ones formed around those dark gray ones, but they also kept a lot of their shape. So we're going to say those formed second. And then it looks like the gray ones just kind of filled in all the extra spaces and don't really have a particular shape that we can easily see. So that was the third mineral to crystallize in this rock. Now, given the choices over here and what we know about the minerals in Bowen's reaction series, that first mineral must be amphibole because it's a higher temperature mineral. The second one must be muscovite mica, and the third one is quartz. Quartz is always the last one to fill everything in as a magma cools. I hope this has been helpful to understand Bowen's reaction series.